Vapor team up here at NCAR, and we've had a user question about how to use Vapor's model renderer over here on the left. It's one of the leftmost renderers in Vapor, and basically what this does is allows you to take a 3D model and apply it to your visualization of whatever you're trying to simulate. The model render is kind of tricky, so I thought I'd make a video showing you guys how to do it. So to give some context, I'm first going to import a WRF file and navigate to WRF and import one of our Katrina datasets. And let's see, the image renderer always gives us a good frame of reference for where we are. So in my image tab, I'll select my installed image with that button right there. I'll pick bigbluemarble.tms. I'll apply it, and then there is a terrain image of one time step in our Katrina simulation. There's Louisiana right there. So now to show you guys how the model renderer works, we'll go to the Model tab, and basically to load a 3D model object, I typically use STL files. You specify your file, and you'll notice that Vapor by default points you, or it kind of guides you through this file picker to choose a VMS file, which is called it's a file format we made up for models that move in real time, like if you want a spinning wind turbine. I'm not going to cover that kind of thing right now. I'm just going to do a static 3D model file. So I have a STL file. If you go down here, at least in OS X and on Windows and Linux, there should be an option to specify the file extension. Right here we have VMS selected by default, or you can also pick 3D models, and all these guys are 3D models. There's a long list of them. STL is right here. That's very common, and there's a whole bunch of other ones out there too. But I'm going to click on that, and that's going to enable me to pick my target, which I have a STL file of Mount Fuji. Fujisan.stl. I'll select it, point my model renderer at that target, and now I'll enable it. And we're going to see what we typically see, which is nothing in the model renderer. And the reason is that because we are looking at right now the extents of Hurricane Katrina's simulation file. Vapor by default, its coordinate system is meters on the Earth. It's not latitude and longitude from 0, 0 lat long. We convert it into meters so we can perform things like flow integration. So the Fujisan STL file right here, it most likely has its coordinates in unit coordinates from 0 to 1. So what I need to do next is probably, since it's from 0 to 1, in this my region right here for Hurricane Katrina, let's take a look at where our region is. My minimum x bound is about -1 million. My positive x bound is about 2 million. For y, it's from 2.6 million to almost 4 million. And from z, I'm going from 31 to 20,000 meters above ground. So what I need to do is uncheck this crop to bounds checkbox. What this is doing is it's saying any model that's outside of my domain is going to be cropped. It's going to be thrown out. So I'll uncheck that. We still don't see Fujisan because, like I said earlier, it's probably in unit coordinates. So the next thing you're going to have to do is scale it. So I was playing with this earlier. I already know. I think, well, let's see if I can remember right. 10,000 on the x by 10,000 on the y by 20,000 on the z. And the one thing I haven't done, oh, there it is. It's hard to see because I've given it a white color. I can select its color, turn the red down, give it a turquoise color, and there's Fujisan. Outside of our domain, it was being cropped before, and it was just very, very, very small compared to the size of the domain of our geophysical simulation. So those are some of the things that can go wrong with the model renderer. The scaling, the translation can also be a problem. I can translate it on X, Y, and Z. So if I translate this by, I don't know, let's translate it by 1 million on the Y. Whoops, I went the wrong direction. I'll go negative 1 million on the Y. Well, I'm not sure where it went. It might be outside of my frustum right now, which is like another clipping plane in OpenGL. Maybe I'll start with something smaller. 10,000. Another thing to note is that these operations, the scale and the translation, they occur in a certain order, so that if you scale something, you're going to translate it by how much you scaled it. Because it gets scaled first. So it looks like I'm translating this by 1 right now, but no, it's being scaled by 10,000 first. So I'm actually scaling it by 20,000 right now. And I can just nudge it bit by bit. So just remember, there's an order of operations here that are going to affect where your model gets placed in the scene. So that was a brief tutorial, I guess, on how the model renderer works. I hope it helps some of you guys get some of your geometry into Vapor.